Hello everyone, my name is Steve Samuel from Design Visionaries, and today I'd like to do a algorithmic model, or show you how to do an algorithmic model of a Phyllotactic spiral. And in the last video I went through some of the math. We developed this number 1.618034, and we also saw that 137.5 degrees was this special number that derives from this math. It's the golden rectangle. It's the golden ratio for angles and so on. So to see more about how I arrived at that, you can look at my last video. But today I'd like to show you the algorithmic model that I made that's based on all the math. So here's the algorithmic model, and as you can see I have number of holes here. I can change that number. I'm going to put 300 in. So you put 300 and it does that. And I also have a start diameter and an end diameter. So if I start at 4 and end at, let's say, 10, then you can see how I can manipulate this model, and it's you can see it's really quite simple. But I thought I would go through every last little detail of how to make one of these, so you really knew exactly what I did with no mysteries whatsoever. So the very first thing I'm going to do is go to the algorithmic modeling feature and start putting stuff on. So now I have a kind of an outline in my brain as to how to make this. And what I'm going to do is I'm going to create a line, and I'm going to create endpoints on that line. So I'm typing in endpoint. There's that, curve endpoint. So I'm going to need that. And I'm going to need circles at the end of each endpoint. So right away, those are three blocks that you can understand. I'm going to create a line, and then I'm going to rotate it, and then create another line, and rotate it, and create another line, and rotate it. Each time I rotate, I'm rotating 137.5 degrees. So I need a number input. The reason why I'm using this number input is because some of the blocks, when you input from the blocks, they give you integers, so you can't put in the required angle. So this is 137.5. This is going to be my input, and actually this is a number when I write this out as, let's say, a snippet, or when I see it as a algorithmic feature. I don't actually want to see this. I'm never going to change this number. I could change it within the algorithmic model, but I'll never change it as a user, so I'm not even going to label that. So the mentality here, or the modus operandi if you want, is we're going to create a line, we're going to rotate the line, we're going to put an endpoint at the end of the line, and we're going to put a circle at the endpoint. So I can put the line into the curve endpoints. I could put endpoint into center point of circle. So right away, all of that makes sense, right? The diameter, I'm going to have a range. So there's a nice little node called range. Awesome. And I'm going to have a start. So if I say create input, let's start the range at 4, and let's do an input of the end, or the largest circle. Let's call it 8, and let's rename these. So we're going to say start diameter, and this one is going to say end diameter. So anybody using this will know exactly what to do. End diameter. And we'll have the divisions. I'm going to do something a little special with the division, so I'm not going to do that right away. But I can put this into diameter right there. Okay, beautiful. Now, when I rotate my line, I'm going to be rotating it about the z-axis. So I'm going to be placing all this geometry on the xy plane, and I'm going to be rotating about the z-axis. And so I'm going to type in z vector. Here's a z vector for us. And we're going to put that right here. There's a z vector. And while we're at it, the circle is going to need a normal vector, and that's the same one, right? Z. So I'll pop that in there like this. Come on. Click on the little doodad and put it right there. Okay? Beautiful. Reference vector, we don't really need that. That just tells you where the circle starts and ends, so it doesn't matter. Now, the line, where we're going to start this whole thing is at 0, 0, 0, and it's asking for a point here. And so I'm going to go to the points mode. Where are the points? Right. Here it is. I want this kind of a point, an XYZ point. And that is where the line starts. So I'm just going to pop that in there. That's interesting. Okay. And then the length, we're going to be varying the length. But the length is kind of sophisticated. I'm not going to deal with it right now. But basically, I've got a line. I've got the curve at the endpoints. I've got the endpoints at the end of the curve. I've got a circle endpoint, so this is all good. I'm varying the circle from 4 to 8 with a divisions that I'll show you in a moment. And now we have to rotate that line. So there's two things to rotate. There's rotate vector, and there's rotate input geometry. And what you will discover about rotate vector is the rotation has to be put in radians. So I'm not going to use that one. I'm going to use rotate input geometry. So good. So what we're going to be doing is we're going to be rotating every time we make a circle. We're going to rotate a little bit, 137.5 degrees. And so the geometry that we're going to be rotating is the line. So we have to make the line and then rotate the line and then get the endpoint. So I'm going to push this out. I'm going to push this over here. I'm going to push this up here. And I'm going to put the line into the rotation geometry. I'm going to put the geometry coming out of that into the curve. Oops. So if I do that, as soon as I put that in there properly, it'll take the other one away. See, it only likes one input. So there. So now I'm getting the endpoint of the rotated line. Okay. We're going to be rotating that line about a vector. The vector is the z. So we're going to use that z vector one more time. And that's going to be from there to there. And that's a little hard to see, so I'm going to move it down like that. Okay? Good. And then the rotation point, what we're going to be revolving about is 0, 0, 0 also. So I'm going to put that right into there. Okay, so far, everything's just very understandable, right? Easy. Now we get a little bit more sophisticated. We have to do something interesting on the length of the line and the rotation angle of the line. And so now we need to have an input for the number of circles that we want. So there's a wonderful block called the range. Again, so I'm going to use the range. There's that. And this is such a powerful block, but it's a little bit cryptic in a way, because we're going to start at 0. So there's going to always be 0. That's going to always be our start. And then we're going to have an end that is the number of holes that we want. Here's an input. So if I say 100, so this is why it's tricky. So if I say that we're going to have 100 holes, start at 0 and end at 100, and our divisions are 100, then if we have 100 divisions from 0 to 100, we have 101 holes. Check it out. if I click on this little node point and I say display data, then you can see what's going to come out of that is a list that goes from 0 as the index, let's say, and the first hole, or the first list item is 0. And so then you can see that it says list with 101 objects. So you go all the way down here and you say 100. So this is not going to be 100 holes. This is going to be 101 holes. So that is what is a little tricky to understand about that. So what we're going to do is we're going to have the number of holes we're going to subtract 1 from the number of holes, and we're going to subtract 1 from the divisions, and so it's going to look like this. I'm going to take this line away, delete, and I'm going to use a subtraction box. Subtract. This is just an idiosyncrasy of using the range block. If you want 100, you've got to subtract 1. So I'm going to put a 1 here. There's this. That's 1. And then I'm going to put this into there. So it says simple number. And then I'm going to put this into there. Okay. And I'm also going to get rid of this. And I'm going to put this into the number of divisions. There we go. So what does that do? So now, right here, I'm going to say rename, and that's going to be number of holes. Okay. So when I want the number of holes, when I want 100 holes, since the first one's going to be 0, if I look at this this data now, you can see that the first one is 0 and the very last one is 99, and there's 100 in the list. So that little manipulation is something that, you know, it's not exactly straightforward, or you might not think of it right away, but it's awesome. Okay, so now this number right here, I'm just going to rename it as the golden angle. Golden angle. So anybody who looks at this little program will know exactly what's going on. Okay, so the numbers that I'm getting out of here are 0 to 99, and the angle that I want to get out of here is that number times the golden angle. So I'm going to have a multiply block. Multiply. Here we go. Multiply. So I'll put this over here. I'll put range into there, into A. I'll put golden, whoops, got to click more precisely. And I'll have golden angle into there. Boink. And I'll have that angle into the rotation. There we go. All right, now finally we're almost ready to see the output, but what we need here is a length, and in order to do a Phyllotactic spiral, you have to have the length as the square root of the angle. So that's really cool. So we're going to do, where is it? There's the little square root block. Divide, absolute value, exponent. Where is it? Here it is. Here's the square root block. So what we're going to do with the line length is we're going to take a look at the range, and we're going to say, put the range in there. Come on. In there. And we're going to put that in the length. But wait, there's one little thing. And that is, when we take the square root of 0, we get 0. So we're going to get a line length of 0. So then when we come out of the line block, we're going to have a null line, because you can't have a 0 length line. and you can't really get an endpoint of a zero length line. And I want the first hole to be right in the center. And so I'm going to cheat a little, and I'm going to add a tiny little 0.001 into my square root block, and then that's gonna be the length. So what I'm going to do after the square root block, I'm going to do an add block. Here we go. And we're going to put that square root right here, and we're going to do an add. Now here, right here, so when I do an input to B, as you can see, it's an integer, and if I try to put 0.001 and hit enter, it just goes to 0. So that is a little nuance. So that's why I need a number. The little number block. Okay, so we'll get rid of this one. Delete. And this is going to be 0.001. And I'm going to pop it in here. Boop. And I'm going to push that into there. Okay. And this number of divisions, that's going to be the same as the number of divisions I want on my different circles, right? So I'm going to grab the divisions from here, and I'm going to pop it in there. Okay. Now let's see what we have. So I'm going to output the lines, and it's not doing anything. Oh wait, is it? No, it's not doing anything. Why not? What did I do wrong? I've got number of holes, I've got the start, I've got the end, I'm multiplying, I'm taking the square root, point, line. I'm not exactly sure why I'm not getting anything. Line by direction. Okay, so now, obviously I've made some mistake, and the cool thing is I'm going to debug it right in front of you. So I'm going to look at this and say display data, and obviously I'm getting 0 to 99. Good. So this whole thing is working. Then I'm multiplying it by 137.5, and so I should get a number of really cool angles here. Display data, and the very first one should be 0, and the second one should be 137.5, and so that whole thing is working right there. Good. Then I'm taking the square root of this, I'm adding 0.001, and I'm feeding that into the line length. So let's see what we're getting out of here. We say display data, and we're getting 0, and we're getting 1. I'm sorry, we're getting 0, 1, 1.4, 1.7, 2. So this is good. So this is good. So we should be getting lines. Oh, there's all the lines. Ah, now, what I forgot on the line, I'm getting all the lines that are coming straight up the z-axis. So that is the problem. So when I do a line, I've got point, direction, length, and my direction should not be in z, it should be in x. That's the problem. My bad. You guys probably caught it before I did. So I'm going to say x-axis, x vector. Silly me. So here's an x vector. So I've got to stick this x vector into the vector of the direction of the line, this one right here. So I blew it. I just made a little mistake here. So I'm going to put this in there. All right, and now I'm getting a line. Okay, so there's something still wrong, but at least right now I'll bet you there's just a whole bunch of lines right on top of each other. So I'm not exactly sure what went wrong, but we'll see. So this direction and this point, let's just delete that for a second. Okay, and I'm just going to finish and save. Uh-oh. Uh-oh, what did I do? Okay, let's go back in. Let's edit definition. Okay, and let's figure out what's going on here. So the line direction is X. It's got a certain length. It's about a certain point. Then we're rotating the geometry. We're rotating the geometry about Z. Good. We've got an angle. Then we're putting an endpoint at the geometry. And let's take a look at what happens when we put an output there. Oh, look at that. That is exactly what we wanted. That's beautiful. So those are the points. Now, the question is, why are the points not getting vectors, not getting circles? So we're starting with a circle of 4, and we're ending, oh, because I don't have an output on the circles. There we go. Output. There we go. All right, so this is the whole thing. So now let's see what happens when we start varying the circle diameter, and we should have a working unit. Look at that. We start at 1, we go to 2, and we have the number of holes here. Now, another thing that I'd like to do is space out the holes. I'd like to have a spacing factor, right? So I've got a start diameter and an end diameter, and these are all too tight. So I'm going to have a start diameter of 0.125 and an end diameter of 0.25. And that's too small. 0.25, 0.5, let's say. Look at that. And let's do 2. 1 and 2. Okay, so we have a nice pattern. But I also want to space it out. And in order to space it out, I have to take the line length, and that's going into here, and I'm taking the square root of the angle, and I'm also adding this tiny little bit, so I'll get an actual circle at the very center, which doesn't seem to be happening, by the way, but we'll take a look at that in a second. Let's try one here. Yeah, so that's the first circle, 1 millimeter away from 0. Okay, and let's just do 0.1. Okay, now it's moved in. So now it's working, and let's try 0.01. And let's try 0.001. Okay, so 0.001 is a threshold beyond which, or below which, it won't do a hole. Let's try 0.005. And 0.005 won't work either. So let's do 0.01, and now we get a hole. Okay, so we know that this little threshold has to be 0.01, otherwise you don't get the hole. So we're cheating a little bit, just a little bit. So good. So now we have literally 100 holes. But like I said, I want to space it out a little bit, and so I want to do something interesting with this length. So what I'm going to do is add a scaling factor. So that's going to be a number. So get a little number. And we're going to rename it as scaling factor. Oops, let's spell it correctly. Scaling factor. I've never been a good speller. Okay, because of all the weird little rules and weird little things that happen. So there's my scaling factor, and I'm going to put in 0.5 or 1.5. I'll put in 1.5 to start with, and in order to scale the length that's coming in, I need a multiply box. So I like to type them in so I don't have to go searching through that list. So I just double clicked on it a few times. There it goes. I probably have some extra ones lying around somewhere. So what I'm going to do is I'm going to take the length from here and put it there. I'm going to take my multiplication factor and put it in B, and then I'm going to come out of here and replace there. So there we go. So now I have full control over everything. And I don't want to output the points anymore, so I'm just going to delete that. There we go. All I have now is circles, and I've got this beautiful Phyllotactic spiral that I can vary all kinds of things on. For example, the most interesting thing I can vary is the number of holes, right? So I'm going to go to my number of holes, and I'm going to put in 500, and look at how quickly that just updates and gives you the 500 holes, just like that. And then I can vary the diameter. So I've got start diameter 1 and diameter 2. So I could do 1.1, let's say. Evidently, if I put in 1, it won't do it because it's an invalid range. So you just have to put in a little, like 1.001. So that's really cool. I can have the starting hole be greater than the end holes. So that's an interesting pattern right there, and you can see how beautiful that pattern is. If you have a speaker grill or something like that, you put that on there, people understand that you're sophisticated. This I can get rid of. So there is the whole litany of things that I've done to make the Phyllotactic spiral, to be able to vary the number of holes, to be able to vary the scaling factor, to be able to vary the start and end point. What more could you want? Now, while I'm here, while we have this thing working, let's just do a little experiment. Let's see what would happen if we had not 137.5 degrees, but something else, like 45 degrees. Let's see what happens. See, it all lines up in some weird way. Let's say what would happen with 180 degrees. Well, that makes sense. It's all on one line there. Let's see what would happen at 12 degrees. Oh, interesting. So it's really neat that once you've created this thing, you could do some really good searching. Now, how about if we have 10.5 degrees? Cool. And how about just 0.5 degrees? So that is a really neat tool now that we have, that we can check out all of these really cool scenarios. But 137, how about 120.5? Neat, neat, neat. Okay, and finally, let's go back to 137.5, and we get what we want. So, I hope you enjoyed that. Again, my name's Steve Samuel from Design Visionaries. I teach a whole course in algorithmic modeling. I will literally come to your company and teach. There's so much more to know about algorithmic modeling, and there's so many other awesome surface techniques and things that you can use to make geometry that's really incredible looking. So give me a call, get on the website, designvisionaries.com. You can order a course. I'm going to be writing a book about this, not about the Phyllotactic spiral, but about algorithmic modeling in general. So anyway, please like and subscribe. Help us out on the channel. I hope you enjoyed this. I certainly enjoyed doing it, and I'll see you next time. Thank you.